afternoon, everyone. My name is Muhammad Irfan Alam, and my supervisory team is Dr. Amal Ali Al-Kurdi and Dr. Tim Paget. I'm from University of Sunderland, UK. Today I'm going to explain briefly about part of my research work, that is local mucoadhesive drug delivery against Helicobacter pylori, and the local area is stomach. So basically, the target microorganism in my research is Helicobacter pylori. Before we move on, I just want to give you a brief introduction of Helicobacter pylori, what is that organism and what it can do to the human populations. So it's a gram-negative microaerophilic microorganism that grows in the limited conditions of oxygen. If you go here, it affects different parts of the world. For example, if you go to the laser light, this one. Okay, if you see in here the Russian region is 94% plus minus 1, 2, and it affected the American population up to 79%, and the highest rate strikes in the African area. However, 80% region in the Asian countries. So this much amount of population is affected by this microorganism. And the diseases it could cause is, the most common is acute and chronic gastritis, which is most common diseases, and if it remains untreated, it can be converted into the multiple lymphoma and gastric ulcer and further gastric cancers. So currently, by the consensus of different clinicians, the current therapy is known as triple therapy. That's based on the two different antibiotics, combination of two antibiotics and one proton pump inhibitor. But sorry about that. Proton pump inhibitor. The combination of antibiotic could be amoxicillin, clarithromycin, and metronidazole. But the main problem is it creating some problem? But the main problem in using these antibiotics is developing resistance against these microorganisms. If you see here in this slide, different conventionally used antibiotics are amoxicillin, clarithromycin, tetracycline, and metronidazole, and the bars represents the different resistances. For example, the metronidazole using in Russian area is 37% resistant, and 92% resistance can be found in African region of the for the clarithromycin. So at this point, we need to use some antibiotic that poses the least or very low antibiotic resistance against this microorganism. So one of the candidate drug is furazolidone. Furazolidone is actually gives very low resistance against this microorganism. You can say even up to 4-fold less resistant than the clarithromycin and amoxicillin. But as this drug is associated with the number of side effects, so in this project, basically what we did reduce the amount of the dose that is sufficient to combat the Helicobacter pylori, but to get rid of the associated side effects. So for using this approach, we have used local mucoadhesive drug delivery system by using two different approaches. One of them is microsphere, and the other one is, microparticle, and the other is liposomal drug delivery system. So in here, if you see here, this is basically 3 layers of stomach. Basically, it's 1 layer of stomach with the 3 different zones of the pH. Going from the lumen to the serosal layer, if we go from inside of the lumen pH is about pH 2, and the upper mucus layer is pH 4, and where the Helicobacter inhibitate is about pH 7. So in my project, what I did mucoadhesive drug delivery system, and the target of my mucoadhesion is on the interface of the mucus layer. So we did the experiment in 2 different conditions, that is pH 1.3 and pH 4.5, because the mucoadhesion site is interface. And let's move on to the next slide. What's the mechanism of action of this microorganism to cause the ulcer? Actually, this microorganism, if you see the triple therapy, 2 antibiotics and 1 PPI, that is proton pump inhibitor, it could be omeprazole, whatever it could be. So what it does, it secretes the urease enzyme that converts the urea into carbon dioxide and ammonia. and the ammonia produced is toxic to the epithelial cell. For example, if you see here, the Helicobacter pylori come to adhere on the mucous surface and then convert the urease into ammonia and carbon dioxide. This ammonia erode the epithelial layer, followed by the pepsin invasion, cause the ulceration in here. So aims of research, as I have explained you before, that why we have selected two different pH. One is the post-PPI condition, and one is natural pH of 1.3. So methodology, we have used different approaches, microsphere, microparticles, and a liposomal drug delivery system. So we have used two different methodology. For mucoadhesive liposomal system, we have used fluorometry, which was further confirmed by the fluorescent microscopy. And the mucoadsorption of microparticles were done by calorimetric method. It is well-established method, can be found in any related research article, and I have provided with the link at the end of the presentation. So now, due to lack of time, I didn't explain every single step of the methodology. However, I put that in the appendix methodology, and if anyone wants interested and wanted to discuss the stepwise methodology, I am more than happy to answer address any queries. So mucoadhesive liposomal drug delivery system. Okay, so key fact and the key results explained in these next 4 slides. First of all, we have used the glutaraldehyde for the preparation of the microparticles. Why we use this glutaraldehyde? Because to get the smooth release, not the abrupt release, or to get the smooth release in the up to the duration of 6 hours. That is proposed by different scientists, the mucus slough of time, natural mucus slough of time. And as we use the glutaraldehyde, it has some natural negative impact on the mucoadhesion because of the hardening effect. So in our research, we have balanced the amount of the glutaraldehyde and the amount of the mucoadhesion to get the maximum benefit of the mucoadhesion and the drug release uniformly at the same time. So if you go here, it shows the negative effect, as I have explained before, that by increasing the amount of the glutaraldehyde, the hardening effect caused the decrease the mucoadsorption. For example, in here, the least amount of the glutaraldehyde, that is 1%, give the maximum mucoadhesion of 60% up to 6 hours. Then the effect of pH. The effect of the pH shows the positive effect on the adsorption or the mucoadhesion. Because if we go, we use chitosan as a polymer, mucoadhesive polymer. So as we go from acidic to alkaline conditions, it is more stabilized and and show the mucoadhesion. It adheres more strongly to the adhesion to the stomach layer. While acidic environment has negative effect, because as we drop the pH, the amino groups on the chitosan, they get protonated, and the hydrophobic interaction between them, they become weakened and solubilize the chitosan. And if our assembly is relying on the chitosan, and if it is solubilized, so it means that we are having no more mucoadhesion. So it shows that as we go up to the pH 4.5, like here, these are non-chitosanic systems, nanoparticles used as a control. For example, in here, we have used we didn't use any chitosan, so up to the 6 hours, it drop off all of the liposomal drug particles. They drop off the mucus. However, at pH 1.3, 40% retained, and at pH 4.5, 80% of the formulation retained on the stomach up to 6 hours. We selected this 6 hour because the natural wash off time of the mucus is 6 hours. So if you go beyond that, there is no point of going beyond that mucoadhesion, because if there is no mucus, there is no point of going beyond that 6 hours. And similarly, these results were further confirmed by the fluorescent microscopy. If you see here, this is the mucoadhesion showing by the fluorescent. These are the stomach tissues of the sheep, and it is bound by the few quite a while, I can say, liposomes, and as the time progresses, it loses its liposomal particles. And similarly, if we go at pH 4.5, you can see here at 4.5 and 6, we still got some liposomal particles on that. And then methodology appendix that I have explained you, that if anyone wants to, if anyone is interested in stepwise methodology, how we exercise this sheep's stomach and how we did the dissolution of that mucus and different things. So it's given in the methodology appendix. And that's it. Thank you very much. Yes, please. Oh, yeah.
Thanks. I'm just a little bit confused. I mean, what are chitosan particles? I mean, what are chitosan liposomes? I mean, I'm confused about the particles you are using. Are these liposomes?
Liposomes.
Or liposomes and liposomes are the same.
No, liposomes. Made up of lipids and cholesterol.
You are using also, you mentioned chitosan.
Chitosanic liposome.
What is this?
Sorry?
What is this?
Oh, these are actually the liposomes prepared independently and then using the polymeric solution to give them mucoadsorption. So we have combined the liposome with the chitosanic solution.
Have you characterized these vesicles?
Yes, we have characterized it, and it's already in publishing European Journal of Pharmaceutics, but only I have presented the part in here, and the rest of that characterization is on that. And I can provide you with the list.
How you know this 1% this acid which glutaraldehyde is your optimum level, and
we have used different.
And this chitosan with this glutaraldehyde, it is a chemical cross-linking process, and it controls this, of course, the release of the drug.
Yeah.
But how you just you have optimized or?
Yeah, we have optimized different concentrations of glutaraldehyde and chitosan, as I have shown in the figure. 3 different concentrations of this 1%, and then for 2 milligram, 4 milligram, and 6 milligram. Different concentration, different amount of the glutaraldehyde was used in the formulation, and then were optimized by it.
Okay, there are many factors are there remaining unanswered.
Due to limited amount of time, so I have just.
It's basically a microsphere.
There are 2 different approaches. One of them is microsphere, and one of them is liposome. But both of them use similar polymeric solution.
What is the mechanism of mucoadhesion?
Actually, there is mucus is negatively charged due to sulfate and carboxylate groups on 6 and hexyl acetylamine, and the chitosan is positively charged due to a minor group, and there is an electrostatic interaction between them.
Okay, thank you.
Okay, thank you very much, Mohammed. Certificate time?
Thank you very much.
Well done.